we all know that marine debris is not just a problem for our oceans, it's also a problem in the Great Lakes. An estimated 22 million pounds of plastic are found in the Great Lakes, put in the Great Lakes every year. The Council for the Great Lakes region has led efforts to mitigate marine debris and primarily plastic debris in the Great Lakes through the Great Lakes Plastic Cleanup. It brings together collaborators from across the binational Great Lakes region to take action on plastic pollution. Partners from throughout the Great Lakes have deployed innovative technologies in mitigating plastic debris in the waters of the marinas and also the beaches. And some of these partners will share their approaches to this effort and show what has and has not worked to help alleviate plastic debris in the Great Lakes. Today, we're going to hear from Allie Walker, Program Officer for the Council for the Great Lakes, Jamie Cross, Shipboard Science Instructor at Grand Valley State University and Annis Water Resources Institute, Katie Rademacher, Research and Restoration Manager at Milwaukee Riverkeeper, and Greg Kleinheinz, Director, and Brittany Dupree, Lab Manager at the Environmental Research and Innovation Center at UW Oshkosh. They'll all be speaking to us for about 40 to 45 minutes, followed by a Q&A. So please make sure to submit your questions in the Q&A button at the bottom of your screen so that we can make sure that all the speakers have access to those and are ready to answer at the end of their speaking. So this event is part of the online Great Lakes Freshwater Symposium series, a partnership between the Freshwater Collaborative of Wisconsin, the Great Lakes Higher Education Consortium, and the Council of the Great Lakes Region. Take it away, Allie.
Thanks, Marissa. All right, let me share my screen here. Start presenting. There we go. Come on, there we go. Okay, so thanks everyone. I'm here with the Council of the Great Lakes Region. I am our Program Officer of Circular Economy, and I help to coordinate the Great Lakes Plastic Cleanup Program. So I'm going to talk a little bit about the context for the program, as well as some of the overarching administration, how it works, and then I will let our wonderful partners dive into some of the details of their implementation of the program. So I will go ahead and just give a quick description. So the GLPC is a joint initiative between ourselves, the Council of the Great Lakes Region, as well as the Canadian Environmental NGO Pollution Probe. And Pollution Probe operates the project in Canada while we take the US operations. So anything I speak of today will be with that US lens, but we do operate in both countries. And so what we do with this project is we deploy innovative catch basin and litter capture technology to remove plastic litter from the basin, but also to bring attention to the issue of plastic waste and litter in the lakes through community engagement, as well as data collection, and using that data to drive interventions to help fix this issue. So as I mentioned, we operate with many of with the partners that are on today, but then also many others. So I'd like to bring attention to those folks first, our funders, as well as our American partners. And if there is any interest in being along the likes of Meyer, the Clorox Company, or TC Energy in sponsoring the Great Lakes Plastic Cleanup, please don't hesitate to reach out. We'd love to discuss how we can get you involved. And again, just another thank you to all of our American implementation partners, many of which you see here today, but then the others are with us through these logos here. And they help operate the program across the region. So Marissa spoke to it a little earlier, but I want to just give some context to the importance of the Great Lakes region as well as what drove us to start this project. So in our consideration, and when I say the Great Lakes region, we're talking about the entirety of the 8 US states that surround the lakes, as well as the 2 Canadian provinces of Ontario and Quebec. This region is home to 110 million people, so a very large chunk of the US and Canada population. It would be the 12th largest country by population if it was its own country. Also with a massive GDP, providing millions of jobs and opportunity for recreation across the region. And then, of course, we all know that it holds 20%, over 20% of the world's surface fresh water, which is a resource that we aim to protect. Especially as it provides drinking water to over 40 million people. However, while I think we can all agree how important the lakes are, we are facing a challenge, and that is the issue of plastic waste and litter in the lakes. And so I believe it was mentioned earlier that there's estimates that say that 22 million pounds of plastic are entering the lakes every year. We also note that 80% of lakeshore litter in the US and Canada is plastic. And there have been studies that have found really high concentrations of plastics and microplastics in Lake Superior and beyond. So all things to be concerned about, which is why, here we go. Which is why we started the program. So before I move on to exactly how the program works, I wanted to touch briefly on the technology that we use at the GLPC. So you'll see on the left, starting left to right, the Beebot. It is a beach robot, and I'm certain our partners will discuss this a little more in depth, but it is almost like a little tank that goes along the beach and sifts the top layer of sand, limiting disruption to wildlife and dunes, while sifting out plastics that might be difficult or impossible for humans to collect on their own and just clean up. We also have a water drone. This is remote controlled. And can skim the top of the water. And we have additionally some programming with catch basin technology known as the gutter bin. And that sits in the stormwater and filters out pollution and prevents it from entering into urban waterways. Moving on. So just talk briefly about how we implement this project. So CGLR plays a supporting and administrative and coordination role to our partners that are really the implementation partners. They really handle that piece, and we rely on their expertise in their regions and in their areas to identify locations, work with different community engagement events throughout the summer, identify additional partners. They know the lay of the land in their areas far better than we do, so we rely heavily on them for that. But then we do provide that support by offering resources, as well as we have a bi-monthly meeting forum to meet with everyone, introduce everyone, understand who else is doing the work, but also solve problems, check in on progress, and have discussions as needed. To touch briefly on what the program entails, we ask that partners operate their devices around 20 times per season, try to get them out weekly, completing 6 detailed waste characterizations. And I want to thank Jamie for this photo below, because I believe this is hers. This is kind of an example of how we have folks sort the debris that is found. And we don't ask that this is done every time, but we do ask for a minimum of 6 each year, just so we can collect that data. We also ask for a participation of at least 10 community engagement events, posting on social media, doing some press releases, and final reports, just so that we can consolidate all of the data in one place. And before I turn it over to our partners, I'm going to just briefly touch on some of the achievements that we've made thus far. So far, since 2020, the project on the whole has collected and characterized over 245,000 pieces of debris. And that is not our entire expected impact. As I mentioned, every time these are run, we are not doing the characterizations. So that is just a small percentage of it. That's just what we have characterized and cataloged. We have 162 devices across the Great Lakes region in the US and Canada. Last season, we're still working on finalizing the 2025 season data, but the season before, 102 cleanups were conducted across the region. 68 unique locations were cleaned. Over 12,000 community engagement events were hosted by our US partners. Oops. Let's switch that. So 113 community engagement events were hosted by the US partners, reaching over 12,000 community members. So we've seen a lot of success, particularly with our community engagement. But with that, I want to thank you. And I will pass it over to Jamie.
My name is Jamie Cross. I'm with Grand Valley State University's Robert B. Annis Water Resources Institute. Our pilot campus is on Muskegon Lake in West Michigan. Our organization is a multidisciplinary organization that falls under Grand Valley State University's College of Liberal Arts and Sciences. We work to integrate research, education, and outreach to enhance and protect freshwater resources. Our institute has multiple scientific labs in it. We have a really robust, awesome internship program, and we also have 2 shipboard science vessels in which students and adult learners have an opportunity to do hands-on freshwater science. One of my roles at Grand Valley at the Water Resources Institute is to facilitate the work under the Great Lakes Plastic Cleanup, and specifically we run the BBOT in Muskegon. We were the first to get, I think, the BBOT in August of 2022. As Allie mentioned, the project goals are pretty simple. Just remove plastics from litter from beaches and waterways, gather data, and then conduct outreach. So here's our BBOT. There was a naming contest. Allie didn't mention it, so I will. Mario did a naming contest to individually name each of our BBOTs. And so ours is called the Laker Raker because we are GVSU Lakers, so it's an appropriate name for our BBOT. It has been a great name for it. So on the left are a couple of our interns. You can see the BBOT is run with a remote control. The back drops down there and it digs a little bit into the sand and it vibrates as it moves along the sand. And so there's a screen inside where the sand drops through, and in the back, it collects debris. It's non-discriminatory. It doesn't just pick up litter items. It picks up anything that it comes across, rocks, anything, shells. That debris is brought back to the Annis Water Resources Institute, where we weigh it when it's dry, and then we drop it in the water. So some things will sink, like rocks and shells, and everything else floats. We go through and meticulously separate everything. We pull out the litter items and the wood, and I'll talk about the wood later, what we do with it. Next, everything goes, here's the picture that Allie showed you earlier. Next, everything gets dried, the litter items, we catalog those and then separate them and count them. We do at GVSU actually go through this process with every run that we do. And then that information is actually entered into an online system that the Great Lakes Plastic Cleanup has, so that data that we are collecting is accessible to the general public, but is also collected collectively. Just really briefly, I want to give you a little picture of some of the top 10 items we collected in 2025. So this pie chart represents the top 10, but the 111% there is everything else that's not the top 10, which is all different variety of things. You can see that by far, the majority of the things that we picked up were hard plastic fragments. So plastic fragments are those items that come from everyday plastic items that get broken down over time to the point you can't even determine what they are, where they came from. And of that percent, they were under 3 centimeters. And then you can see the other items over here on the left. So overall, as Allie said, 80% upwards that we collect is plastic items. If we look just specifically at the plastic fragments that we collected in 2025 in this pie graph, you'll see 92% of the fragments are under 3%, and the rest are the over 3%. But what's really critical about this is that these items are being removed, which Allie mentions hard for humans. It's also hard for commercial cleaning machines to pick up the smaller things. They will never become microplastics that enter the lakes. Something that's really unique about the BBOT is pictured here with these two guys just looking in the back, checking out what I found. The BBOT attracts people no matter where you are, where you go. They just come up and actually talk to you about it, and a lot of interest. So that's been a really fun part of it. The wood we take out and separate, it gets dried. We are working with Goodwill Industries of West Michigan here, who does a lot of sustainability programs. And the idea will be to recycle this wood into products. So they're working on the equipment, finalizing, getting the final pieces of the equipment. Hopefully we'll see this in the next year happen. There's also some hope that we'll be able to take the plastics we have and recycle those, and that would go beyond recycling what we normally can recycle in terms of plastics. One of the biggest parts of the project is the outreach and education component. As I mentioned, the BBOT it just attracts interest wherever you go, so it sparks conversations. And so we have been at big events with Meyer, inside at Meyer stores. A lot of what we do is right on the beach where people are either doing a beach cleanup. So we go down and demonstrate. We participated in the Great Lakes Surf Festival, which is a big festival on the beach. So a lot of outreach and education as we go. On the left, upper left, those are students from Spring Lake Elementary School. So we've had opportunities where we do education programming at the Research Institute with schools. These kids are actually going through and they're separating in a scientific method and recording everything that they find so that they get that experience. Overall, what we've learned is that the BBOT it removes everything. It's non-discriminatory, so litter items, shells, rocks, wood. And it works best on dry beaches. When sand is wet, it clumps and it's just heavy and hard to go through. And it really removes a lot of the smaller items that the big machines are not able to pick up. And where I run the machine, there is a commercial machine that runs, and we still pick up lots and lots of pieces that the bigger machines can't get. And that most of it really is broken pieces of plastic. And I think that's something we have to look at overall is like, how are we using plastics? And we need to rethink that. The BBOT is definitely an excellent outreach and education tool. And just this last one's just a really fun fact. I get this question over and over. Have you ever found a wedding ring? The answer, no. So I want to thank the Council of the Great Lakes Governors, Region, Meyer, Great Lakes Plastic Cleanup, and the Pollution Probe, our umbrella organization, the different project partners, which some you'll hear from today. Dr. Alan Steinman at Annis Water Resources Institute. This project is in his lab, but it's also, I appreciate him inviting me to participate in this. Our fleet captain that takes care of all the little maintenance issues and actually helped us to get the launch, the city of Muskegon, who's really super supportive of this project. And we actually have a NOAA field station right on Lake Michigan, so we're able to house the BBOT and walk it down to the beach when we go. And lastly, the organization groups and individuals that have joined us on the Laker and the Laker Raker on our journey with the Great Lakes Plastic Cleanup. It has been a lot of fun and it is very interesting. So thank you. I'm going to turn it over to the
everyone can see my screen all right?
Yes, please.
Okay. Thank you. All right, cool. So I'm Katie Rademacher. I am the Research and Restoration Manager here at Milwaukee Riverkeeper. We are a science-based advocacy organization working towards fishable, swimmable, and drinkable waters in southeastern Wisconsin. So we work primarily in the Milwaukee River Basin, which is about 900 square miles in southeastern Wisconsin. And our three major waterways that we work on are the Milwaukee, the Menominee, and the Kinnickinnic rivers. All three of these rivers meet downtown here in Milwaukee before flowing into Lake Michigan. And yeah, so today I'm going to talk a little bit about two programs that we work on to prevent plastics from getting in the waterway in the first place, and then highlight the work with the BBOT and the Pixie drone to remove the plastic that ends up on our beaches. All right. So Milwaukee Riverkeeper puts a lot of focus on keeping plastics and other waste from entering our waterways in the first place. And ultimately, this work lessens the amount of plastic from making its way to our area beaches. But we still know, as you can see from this picture, that plastics are getting there. And those two major programs that contribute to this work is Milwaukee Riverkeeper's Adopt a River program and the coalition that Milwaukee Riverkeeper helped to found, Plastic Free Milwaukee. A little bit about Adopt a River. It's very similar to Adopt a Highway concept. Groups, schools, businesses, individuals can adopt a section of a waterway and commit to 2 cleanups per year. And in 2026, we have about 100 adopters across our 3 major rivers that are committed to cleaning up these riparian areas to hopefully prevent plastic from making its way to the area beaches. And I forgot to say one thing. I'm just going to rewind real quick. So here in Milwaukee and probably a bunch of other places around, any debris that's on our streets or landscapes is eventually going to make its way, whether through snow melt or rainwater, into a local storm drain. And here are our local storm drains. For the most part, we do have some combined sewer area, but for the most part, those storm drains then flow directly into a local river or stream. And like I said, our 3 streams then flow into Lake Michigan. So sometimes I feel like people don't know that the storm drain is directly connected to our waterways. So I just wanted to rewind real quick and say that. So yes, as part of our Adopt a River program, we also host an annual spring cleanup every year around Earth Day. This is an exciting time for us. It mobilizes about 4,000 plus people, and on a single day, we typically remove over 100,000 pounds of trash from entering our waterways. Through audits of the trash that we collect, we know that 85% or more of the trash found during the cleanups are single-use plastics. And if anyone in the audience is from the southeastern Wisconsin area, a reminder that our spring cleanup is April 25th from 9 to noon if you're interested in pitching in and helping with that. And then the other effort I want to highlight real quick is a group called Plastic Free Milwaukee. This coalition, which Milwaukee Riverkeeper helps to lead, works with local groups and volunteers who are interested in eliminating the use of plastics in the first place. And then the one program as part of the coalition that I'm going to talk about today is the Lake Friendly Business Program. So this program works with local businesses to support them in eliminating single-use plastics at their business. This is often like restaurants. And a Lake Friendly business commits to replacing to-go containers with sustainable alternatives, eliminating single-use plastics like on the table, like, plastic silverware, things like that, skipping straws in the first place, and then also using alternatives to plastic bags with their to-go products, among many other things. But Plastic Free is doing a lot of the heavy lift to prevent the plastic from, even getting on the street before it ends up in our waterways. And again, if you're local to the Milwaukee or southeastern Wisconsin area, you can support Lake Friendly businesses and see a list of them on plasticfreemke.org. Excuse me. So we know plastic doesn't break down, it just breaks into smaller pieces. And those two projects are an effort to eliminate plastic from entering our waterways and ultimately ending up on our beaches. Unfortunately, we do know that plastic is making its way into the waterway and then ultimately flowing down the river, bobbing around Lake Michigan for a while before being washed up on area beaches. So that is where the Great Lakes cleanup comes in, and where we deploy both our BBOT and a Pixie drone to clean up those small pieces of plastic. Sorry, it's very dry in our office. So like Jamie mentioned, our beaches too do have they're often all county beaches, and they do have large sifters that sift for big pieces of plastic and debris. But the BBOT really can pick up those smaller pieces of broken down plastic. So for the past 2 summers, Milwaukee River Keeper staff, community members, and volunteers have been working to collect plastic and other trash using these 2 devices. And these are just some pictures from that. The top right one you can see downtown Milwaukee in the background. This is at Bayview Beach, which is a quiet little beach just south of the city that is not combed by a county beachcomber. The bottom right is kind of an image of what we often collect. We are on the west side of Lake Michigan, so our beaches are a bit rockier. So we do collect quite a few rocks while we are collecting plastic as well. And then we also have a Pixie drone. So kind of in the middle here, you can see us launching the Pixie drone. We always laugh and say it's like from the movie Free Willy when it gets launched from the School of Freshwater Sciences, which is where our offices are. And a lot of the work we do with the Pixie drone is going to be in areas behind a break wall, so marinas and harbors. And then I just want to highlight in the bottom left is in August of this past year, Milwaukee had some historical levels of flooding that flushed a lot of debris down our rivers and into Lake Michigan. And there's been many efforts to remove the large debris, but I think going forward, this plastic removal project on beaches is going to be really important as that plastic breaks down further and again ends up on the beach. All right, so the fun stuff. So I'm just echoing what Jamie said too. The BBOT is eye-catching, and people are very into it, and it is a great outreach tool. We've been able to bring it to so many events over the past 2 years. We brought it to the Waterkeeper Alliance Convention, which was a global convention held in Milwaukee. We bring it to a lot of tabling events. This past summer, our local Discovery World put on a Touch a Truck event where a bunch of like fire trucks and stuff come for kids, and we were able to bring the BBOT there. So I think that was a really cool event and got to capture, a different audience than the river focused audience. And also we did a cleanup with the Milwaukee Bucks following that historic flooding last year. It was fun to have the BBOT there. And the BBOT did like a dance off with Bango, which is the Milwaukee Bucks mascot. And then finally, I want to highlight as part of the naming competition, people submitted their names and we went with the name Taylor Sift. So we really lean into that and play off of that fun name. And yeah, our BBOT also has googly eyes, which people really like. And yeah, so the BBOT is a really great outreach tool. A little more, I think the Pixie is a good outreach tool when we're actually deploying it and gathering people around us asking questions. But driving the BBOT into an event, people are really, their ears perk up and are interested in it. So those were the 4 slides I have about our program here at Milwaukee Riverkeeper.
So I'm Greg Kleinheinz. I'm the director for the Environmental Research and Innovation Center, or ERIC, at the University of Wisconsin-Oshkosh. First, I'd just like to thank the Freshwater Collaborative and the Council for Great Lakes region to let us participate. We are a proud and very happy partner with both of those groups through a lot of activities for the year. So you've heard a lot about the BBOT, and you'll hear more about that from my associate Brittany Dupree a little bit later. But I'd like to just back up one step and just talk a little bit about some of the other things that have been done by our group with regard to marine debris, and then also with the Great Lakes plastic cleanup, because the BBOT is only one of the tools in the Pixie drone, the second as part of that program. So where we are, Oshkosh in Wisconsin, which I'll show a map in a second, is not on the Great Lakes, but we are close. And we have two outreach facilities actually on the Great Lakes that have been doing all sorts of work for over 2 decades now. That makes me seem pretty old, but anything coastal. So this happens to be marine debris over the past few years, but cladofera, beach re-engineering and beach closures, E. coli source identification, harmful algal blooms, beach cost, economic valuations, and et cetera. But we don't really have one major population center to deal with. So we have a lot of smaller, mid-sized cities. And so we really take the approach that we want to share technology and resources throughout the region. And so for us, we categorize them into a couple different groups, both removal, so marine debris removal of that material that's already reached the waterways, and then interception technology that stops material from being reintroduced, which could be from a variety of locations. And so we'll see sea bins and Pixie drones. We'll talk about a marine debris boat. I never thought I'd own one of those. Trash cans, just having places to deposit litter, recycling containers, including fishing line recycling. The BBOT you've heard about, some gutter bins, which are stormwater interception technology. And as was mentioned by a previous speaker in Wisconsin, we have very little by the way of combined sewers. So outside of the city of Milwaukee, there's really no combined sewer systems in the state, which is sort of problematic because things just end up jettisoning from the impervious surfaces around the waterways into the lake. But it provides us some opportunity to do things we wouldn't otherwise be able to do, and then some microplastics analysis. And so we're really interested in how much is present, how big and what are the sizes of the things that are present, and then can we use that to help identify its origin, and then can we translate the macro debris that we're recovering into the microplastics that we see. And the ultimate goal of the things that we do with our community partners, while we perform a lot of contract functions and outreach in what we call the Wisconsin idea, which is extending the borders of the university or the borders of the university to the borders of the state, we're really in the education business. And so we employ a lot of students from a variety of majors that are really interested in a lot of this work from a variety of perspectives. And we hope that they'll end up, working in somebody's community a little bit later. So as I mentioned, this is our project area. So on the left, you see a sort of blowout of the Door Peninsula, which is that red area in northeast Wisconsin, and then kind of in the middle upper, you see a map where you can see Manitowoc in the lower right, which is where we have one of our summer laboratories and the southernmost area of marine debris collection. And then as we go through the Door Peninsula all the way to the mouth of the Fox River, I think the biggest tributary to Lake Michigan. So our first removal technology is our OmniCat, or our marine debris vessel, or let's just call it really what it is. It's a trash boat. So nothing glamorous about this. The trash boat goes to a different location every day, 4 days a week. And you can see by a couple of these pictures, I've got a couple more here. The marine debris comes in all shapes and sizes. So you obviously see large, pieces of the marine debris being hoisted by a davit crane onto the deck. And so, right there, we've just collected hundreds of pounds of marine debris, but it's only one piece. And so I think that's an important principle as we think about what the previous speakers have talked about, and I think Brittany will mention later, sometimes we measure marine debris removal in pounds or kilograms, but we also, I think, need to measure it in number of pieces. So while it's great to get this big tire out of there, you could argue that 30 or 40,000 pieces of small plastic debris might be more ecologically problematic, but it doesn't really weigh much. So it doesn't sound all that impressive. Our OmniCat has removed about 4 tons of material. The Pixie drone, which you can see being deployed, it's a smaller crane than the one you saw at the River Keepers at the UW Milwaukee, but we use it the same principle. So we would put it on the deck of the boat. The boat would patrol larger areas, including hand removal if we were close, like you see in the lower center. And then, people with their $1 million boats get a little nervous when we, drive our bigger boat through there. So the Pixie drone allows us to navigate within those marinas and areas where things might be a little bit more difficult to reach. Just some pictures of things that have been removed. And here's the Pixie drone. So again, this was both part of an EPA project and the Great Lakes Plastic Cleanup, just kind of showing you the basket in the front and the controller. And so all college students really love playing with this thing. They even devised a way to hook a cooler to the top of it. So, I guess innovation isn't lost on our younger generation. Oh, there it is. So anyway, another one was a sea-bin, which was tried for a few years. So it's a pool skimmer type of technology that takes floating marine debris within marinas and nearshore environments and collects it as it sort of floats through and provides a basket for it. And the picture you see to the right is just some size characterization of that material. The Bebot, which you've heard about and you'll hear a little bit more about in a minute, about the areas we've put it in. But I think it makes the stories and the previous speakers have explained how it works. And the trailer, I think, is important in the left-hand picture there because it shows how transportable it is. And for us, that's one of the really important pieces to our program, is that the technology is fairly expensive. And I know that there's some questions in the chat that we'll get to about cost. But this way, we essentially make it more cost effective because we can apply it to more locations. And, we've had times, I think the most was 15 pieces of debris per minute in some of the trials. I think the lowest is 2 or 3. But if you average it, we're seeing about 11 pieces of debris per minute, which doesn't sound like a whole lot. But if you run it for, 6 hours a day, 3 or 4 days a week, it can add up to a significant amount of debris being collected. And then I'll turn it over to my associate, Brittany Dupree, to talk a little bit about the outreach events and how we've used the Bebot for educational purposes.
Okay, thank you so much, Greg. So again, I'm Brittany Dupree. I'm the lab manager here at the ERIC lab in UW Oshkosh. So I'm just going to talk about some of the events that we have hosted for the Bebot and then what it's like kind of running it on the beach and the type of things that we find. So UW Oshkosh is located on Oshkosh. We're not on the Great Lakes, but we are on the west side of Lake Winnebago, which is the largest inland lake in Wisconsin. So we are close to the water. So we host some events that reach a variety of different people. We have high school students that we come in for different programs. We work with college students and we also work in the community. So here we had an event at our lab. Unfortunately, we're not right on a beach, but what we did for the students is set up an obstacle course, which you can kind of see in the background here with some cones. And we showed them how it works, what it does, and then let them practice and use it. As Jamie and Katie mentioned, we did have a naming contest where a bunch of people submitted different names and we chose Mr. Sifter because we thought that was perfect name. If you want to go to the next slide. Other events that we do, we have events where we take the Bebot places as well. So on the left-hand side here, we have an event actually at our university where we drove it to the other side of campus and we had students just talking to students at UW Oshkosh about what it does, how they can get involved. And I gave a demo of just showing how it can drive around, how it operates by lowering and lowering the cage and then releasing that to get all the plastic debris out. The middle and right pictures are from an event that a couple of students took the Bebot to. There was a fall festival going on in one of the small towns here. We got to take the Bebot out. They drove it around, got to talk to lots of children because, of course, it is, like Jamie and Katie said, it attracts people. It's an eye catcher and gets people interested. So we got to talk to lots of people at these events. Over the summer of 2025, we ended up talking to over 1,000 community members, which was really great. You want to move to the next slide? Kind of moving into now the events in Manitowoc County. So Manitowoc is on Lake Michigan. It's that southernmost region of the Door Peninsula in Wisconsin. We did quite a few events where we took the Bebot to Myers since it is one of our partners. And the students from last summer really enjoyed taking the Bebot out. They enjoyed taking it to Meijer. And what they would do is park the Bebot at the front of a Meijer store. And then as customers are coming in and out, they would talk about what it does and the marine debris program. And then also, the employees that worked at Meijer were very interested in the Bebot, and they got to chat with a lot of the employees at Meijer, which was great as well. Next slide, please. And then here are some pictures of taking the Bebot out on the beach. So some of the beaches that we take the Bebot to are pretty large, so we'll go back and forth over it a few times. In the middle here, we have our student from last summer who was running the Bebot. There was, again, lots of people when they took the Bebot out that were interested in learning about what it does. There was actually one day that there was a problem with the Bebot. One of the track came off, and there was actually a community member that was out and about and helped them get it back and running. So that was really great. On the left and right here are just some pictures of what it looks like when we get the materials out and what type of materials that we're pulling out of the sand. Some of the most common things that we had in 2025 when it comes to the debris is hard fragment plastics. Very common, just like Jamie was saying earlier. Food wrappers, there was a lot of food wrappers, so like from like a sandwich from a fast food place, those type of wrappers. And then lots of rubber pieces, small rubber pieces, maybe from tires. Those were just the most common types of debris that we found in 2025 in Manitowoc. Next slide, please. And then, of course, this would not be possible without our partnerships. A big thank you to the Freshwater Collaborative, the Council of the Great Lakes region. We work with a variety of different organizations as well. Of course, Meijer is one of our sponsors. Yeah, so thank you so much.
Thanks, Brittany. Thank you to all of our speakers today. If you could all put your video back on as we go through the Q&A, that would be terrific. Thank you so much. All right, we got a lot of questions about the Bebot, so let's start there. So you mentioned dunes for the Bebot. How often do the Bebots visit dunes versus beaches, and do they have a limit for the slope? Who wants to take that one?
Well, I can start. This is Greg. So dunes are relative. So if you if you're at Sleeping Bear Dunes in Michigan, that's a very different kind of dune than we see most places in Wisconsin. So there is no exact slope that you can go up or down. If the Bebot's not loaded and so you're heading down, if you will, down slope to the beach, you're doing some collection, it handles a pretty good grade. However, once the basket fills up in the back, ideally it would be only the debris pieces that you're picking up, but oftentimes there'll be sand and other things in there. It does get quite heavy. And in fact, that's one of the things that an operator has to be aware of. Is that, you can get down to where you need to go, but can you always get back to where you want to go? Because these are pretty heavy. I'm not entirely certain of the weight, but my guess is they go well over 1,000 pounds. So it's not anything that a couple people are going to push or pull up the beach.
This is Jamie. I'll just add a few things to that. I have found that there are times that I need to do switchbacks with the B-bot, so going up at short angles in a certain area. And in terms of the weight, the B-bot actually performs better going backwards than it does forwards. So you can, even if you have the weight on, you can pick it all the way up and back it up better than you can go forward sometimes, just the distribution of the weight. But a slope can be challenging sometimes.
Thanks.
And just to chime in with a quick metric, the manufacturer does suggest limiting the slope at 20 degree grade.
Great, thanks. Okay, we got it asked twice, so we've got to get an answer. How much is this B-bot? I have a feeling people want to buy them for themselves.
And I think I'll take this one, Marissa. So we offer programs for sponsorship for $150,000 to purchase the B-bot and operate it for a year. And then there's also the option to operate any of our B-bots for $75,000 a year. But I believe they cost around 75 to 80. That was maybe numbers from a few years ago. So if you're trying to buy one for your backyard, $75 to $80,000, or feel free to reach out to us and we'd be happy to get you on board.
That's great. Are there any concerns for the B-bot collecting non-trash debris that may be important in the nearshore ecosystem? I think you could answer that along with how deep into the sand is the B-bot cleaning?
I can answer part of that from Michigan. So in Michigan, we do have regulations, and you are required to have a permit to do any kind of grooming on the beach. So the places that we take, so they're approved, like sensitive areas or whatnot. So and where we run it is literally just beach, but have also received permits to do grooming. You can adjust how deep it goes in. I would say maybe 5 inches tops. But it's nice to be able to adjust it too, because if there is wet sand, you can adjust it to lower so you're not clumping and stuff. So it's pretty adaptable, I think.
Yeah, I think this is Greg. That's a question that's come up a little bit. We don't have permit requirements as long as we stay out of the water. But yeah, I mean, the operator, as Jamie said, really gets the touch of this. How far can they go down and still sift effectively? But every place we operate anyway has been highly disturbed and it's highly used. So we really don't venture into any places that would be considered sensitive or not, already subject to some other type of mechanical treatment.
And I want to mention that I've seen both of you, actually, I think all 3 of you, operate the B-bots, complete the characterizations, and then take any of that organic material or rocks, things like that, shells, and kind of pour them back into an area on the beach and rake it around. So there is some returning of that to the beach.
That's great, because that is a question. Do we have an estimate of how much plastics the B-bots or other methods are taking out of the environment versus how much is put in per year? Kind of that's a add-on to what you just said.
I think that's dependent on location. I would say, just based on like where I run the B-bot, where you already have a groomer going through. So, and it's just a very sandy beach. So I'm not picking up a lot of items that would be natural, other than the shells, which are not natural either to the environment here in Michigan, the zebra mussels and quagga mussel shells. So and the one thing we do is we do recycle the wood, but that's whether it's man-made or manipulated or whatever comes off the beach.
Yeah, I think if you looked at it, the 22 million pounds of plastics estimated by RIT to go into the Great Lakes, the BBOTs you just saw here is taking an infinitesimally small amount of that back out of so the flux is definitely still on the inward side of it. But I think it's important that sometimes we may look at 22 million pounds and what can we do as one BBOT or one trash boat or whatever. But if you have hundreds and hundreds of these around the Great Lakes, I mean, I can't help but think it makes a measurable difference. But it certainly is just one small tool in that toolbox of marine debris, both remediation and interception.
Yeah, and I think for us too, just really quickly, it's like I actually am surprised the amount of stuff that is man-made that ends up that we pick up, even like coal ash or the stuff from the coal plant. I get stuff from that and from steel production, and it's an amazing how much man-made stuff we pick up that we don't think of all the time.
And I want to chime in and kind of take off of what Greg was saying, which is while some of these cleanups and the data we're collecting may seem infinitesimally small compared to that 22 million pounds number, some of the purpose of this project is to collect the data that we can then identify ways that things are getting into the environment, stopping them at the source, as well as engaging the community. So there's other benefits other than just cleaning up and picking up the plastics on the beach. Understanding that no matter how many BBOTs we would have across the shoreline, I don't think we would ever be able to intercept every single piece.
And just to add to that too, when it's obviously a great outreach tool, but I think just showing people the debris and the broken down debris is really eye-opening for people too. They know a plastic water bottle is trash, but then when you visualize it in all these plastic fragments that you can't even identify, I think that's really impactful too for like the greater outreach and general education with the BBOT.
Thanks. Anybody know how fast it moves? 2 miles an hour or 17? What do you think?
A little faster than walking pace.
Oh, okay.
At a walking pace. So that's not, I don't know the speed, but
15 miles an hour or something like that, I think is a good.
Allie, do you know? I don't know that.
I don't think it's 15 miles an hour, Marissa, but it is pretty slow. But that is one limitation with the BBOT. If you're using it for beach grooming, it is relatively small and slow. So for very large beaches, like Brittany was mentioning, you basically make repeat trips to it. So it's really not designed for that, but for smaller, contained and more urbanized areas, it works pretty well.
One of the questions.
Go ahead. I was going to chime in and just briefly looked up the speed. So it's suggesting 2.7 to 3 kilometers per hour, or about 1.7 to 1.9 miles per hour. But that also, while you can, I think actually it goes pretty quick just by itself. But as you're sifting, it's definitely something you want to take slower, or you risk damaging pieces of the robot.
Just to clarify, I should have said, I was thinking 15 miles per day. That's what I was thinking. Okay. Yeah. All right. And then how large of this is our last question, everybody. How large of an item can the BBOT handle? Are there limits? And does it ever jam?
Well, I will just say that when you collect things at the beach, it really makes you wonder what happens at the beach when the sun goes down. So we've picked up large rocks, 4 inches in diameter, maybe. It really depends on how far down it goes and or how far down you're actually kind of sifting. But probably 2 inches. In the way the sifter is designed, there is no there is no opening that something has to go through. It travels over the top of a screen. So really you're just, I mean, it could be much larger than that. It's really just gravity keeping heavy objects from going in there. But certainly like a full-size water bottle, plastic water bottle will go into there. And so from a jamming standpoint, we haven't had any of those issues in terms of the debris jamming. Really the only issue would be is if you have really wet sand and you want to dig down too far. The B-bot itself as a unit might jam because it really won't, sift that really heavy sand.
Yeah, I had one of my interns get mine stuck once. So. But it was easy. We just had to back it out, change it. It's just too much at once for it. One of the things I just wanted to mention, I know we're close to closing, is a lot of people have asked, why isn't it remote? And so it would be a nice iteration, but people are so attracted to it. I'm afraid they'd walk right up and get their foot run over. So there'd have to be a lot of things put in place before it could be remote, including like adjusting to the wetness of the sand and, what happens with the B-bot. But I have had that question a lot.
Yeah, if I could I know we're getting to closing, but if I could just add one more thing, is if people are in Wisconsin or want to travel to Wisconsin for the summer, one of the things, as you've heard from Allie and everybody here, we like to show this technology off and share it. And so, certainly from our group standpoint, there's an open invitation for anybody to come and work with our team, visit it in action, if you will, if you want to drive it, knock yourself out. But yeah, we're happy to share lessons learned and things we've done wrong, and show you how it works, when the ice goes out. But anyway, happy to do that.
You're on mute, Marissa.
On the size of the waste that it picks up, does anyone know how small it goes? I'm sure there's a little confusion with it picking up sand versus plastic.
I have picked up plastic pellets, but only when it's combined with wet sand or something. So that would normally drop through. I'm actually surprised even though 3 centimeters that picks up, but I think it's because it combines with other stuff. So
Okay.
It still has a much smaller screen than the commercial.
Okay.
Sorry, the screen is about 1 centimeter, but
Okay.
it collects things that are smaller than that.
Thank you. Well, this has been really great. Thank you all so very much for making time and for giving us your presentations and answering all our questions. We really appreciate it, and we hope to stay in touch.